In this lab, we are going to set up an MPLS TE network between PE1, P1, P2, and PE2, and configure MPLS TE tunnels between PE1 and PE2. Customer site 1 and customer site 3 are going to communicate to each other with layer 3 VPN. We will use tunnel policy select sequence to forward the services traffic over TE tunnel 1 via P1 and TE tunnel 2 via P2. Let's get started. Let's get started now with PE1 router. We go to System View to start configuring the necessary configuration for PE1. I will go to the MPLS view and add the necessary configuration for the MPLS TE, starting with command MPLS TE and MPLS RSVP TE, MPLS TE CSPF. In the lab, interface Ethernet 100 and interface Ethernet 101 connected to P1 and P2 routers. These interfaces must be configured with MPLS TE commands. Interface Ethernet 100. This is the interface connected to P1 device. I'll add command MPLS and MPLS TE. Finally, MPLS RSVP TE. And we'll do the same for the second interface, Ethernet 101. Display this to check on the interface before adding the configuration. It needs to be configured with MPLS, MPLS TE, MPLS RSVP TE. We can now run command commit to apply changes done above. Next step, to apply TE capability for the IGP protocol. We have OSPF protocol already added in process 1, OSPF process 1. We have already applied the network commands to allow OSPF to run on the interfaces connected on the MPLS network as we done before in the previous labs. Now it's time to enable the TE capability for the OSPF. OSPF process 1 from the system view, Opaco, capability enabled, and then on area 0, MPLS TE enable. Now, next step is to configure the MPLS TE tunnels at PE1 and at PE2. MPLS TE tunnels must be established and configured between PE1 and PE2. PE1 must configure TE tunnels with destination to PE2, and PE2 must configure TE tunnels locally at PE2 going to PE1. If MPLS TE tunnels are not configured at PE2 router, the return service traffic from PE2 to PE1 cannot be forwarded because there is no LSP path. The LSP path must be configured for the two directions, from PE1 to PE2 and from PE2 to PE1. Because we are not using LDP here in the lab, we are using only RSVP protocol on all interfaces of the MPLS network in the lab. I'll add two MPLS TE tunnels from PE1 to PE2, and same for PE2 to PE1. The MPLS TE tunnels will be configured with explicit paths. Two paths. The first path for the first tunnel will be from PE1, P1, PE2, and the second path will be from PE1 to P2 to PE2, and same for PE2 for the return traffic. Before I add the MPLS TE tunnels, I will configure first the explicit paths. I configure the explicit path with command explicit path, then the name of the explicit path will be to PE2 via P1. This is the first path, and I must determine here the next hops for the path. I have here on the path two next hops. The first next hop from PE1, the next hop is 101 at P1. Then the second next hop is 100 at PE2. 101 at P1, this is the first next hop. I'll add comment next space hop, then the IP address 00 at P2. 100 is 10.12.12.1. Next is to add the second explicit path. I'm going to use the same but via P2. Two next hops, 101 at P2 and 101 at PE2. Then 101 at PE2. Commit. Now I'll go to add the tunnel interface. I have to add the tunnel interface. The tunnel interface is configured with command interface tunnel. Then the number of the tunnel in format XYZ, X/Y/Z, like that format 0/0/. I can give any number from this range. I'll use 1 for example. And first I'm going to give a description to the interface tunnel. I'll describe the interface tunnel with command description to PE1 or to PE1 via P1. Then I'll give it an IP address to the tunnel. I'll use the IP address of loopback 0, use command IP address unnumbered interface loopback 0, tunnel protocol MPLS TE, to set the mode of the tunnel to be TE tunnel. Then destination. The destination is the loopback 0 of the destination, which will be PE2. The destination here is the loopback IP address is 3.3.3.3. I have here wrong description. I have to correct it. The description is to PE2. Next is to use MPLS TE record route label to record the labels of the path for this tunnel. And next is to configure the MPLS TE tunnel with tunnel ID. Tunnel ID. The tunnel must be configured with a tunnel ID, and this ID is locally significant on the router. It cannot be duplicated locally for MPLS TE tunnels configured on the router, but it can be duplicated on other routers. Finally, I'll give it the explicit path for the tunnel MPLS TE path command explicit path, then the first path I have configured above to PE2 via P1. Finally quit from the interface tunnel and commit to apply all above changes. Next, I'm going to configure the second tunnel. Description to PE2 via P2. IP address unnumbered loopback 0. Then the mode is tunnel protocol MPLS TE. Destination 3.3.3.3, the loopback 0 of PE2 MPLS TE record route label. MPLS TE tunnel ID. If I used 1, it gives me error. The tunnel ID has been used by other tunnel, so I have to give it 2. Then finally, the explicit path for the tunnel using command MPLS TE path explicit path. Then the path via P2. Commit. Now it's time to check on the tunnel interfaces. We have added tunnel interface 1 and 2. They can appear on the list of interfaces configured on PE1 with status up. It means that the MPLS TE tunnel path setup is implemented successfully from PE1 to PE2 via 2 paths, via P1 and via P2. The same configuration from PE2 side. It's now configured with MPLS, MPLS TE, MPLS RSVP TE, MPLS TE, CSPF, and same for interfaces. If the interfaces were not configured with MPLS TE, MPLS RSVP TE, or even MPLS, the MPLS TE tunnels cannot be established even from PE1 side to PE2, and also from PE2 to PE1. Same for P1 and P2 devices. The routers on the core side, if not configured with MPLS or RSVP, the MPLS TE tunnels cannot be established from PE1 to PE2 or from PE2 to PE1. Same for the OSPF is configured with opaco capability enable and MPLS TE enable. If OSPF was not configured on any router, the MPLS TE tunnels cannot be established because there is no advertisement to any TE tunnels all over the path. Now check on the interfaces. We can find interface tunnel 1 and 2 appear on the list with up status. We could successfully add the MPLS TE tunnels at PE2 and PE1 sides. There are some display commands to check on the status of the MPLS TE. We can use command display OSPF1 MPLS TE area 0 self-originated. This command can show the LSA types, LSA type, opaco, and the MPLS TE router ID. It can show how many types available for the LSA TE. Display MPLS RSVP TE peer can display the peers of the RSVP and from which interface the peer is established. Finally, we can use command display MPLS RSVP TE established. This command can show the labels allocated for each tunnel. We can check first on the interface status, display IP interface brief. We can find that tunnel 1 and tunnel 2 created are in up state. We can also check that at PE2 we have tunnel 1 and tunnel 2 are in up state as well. We can see here that we have VPN instance created with name customer A, and this VPN instance is configured already with root distinguisher and root targets as we did before in the lab. We can see interface Ethernet 102 configured to be binded to VPN instance customer A, and it has an IP address, is connected to CE1 router. We can also find that BGP is configured and VPN v4 family is enabled with peer 3.3.3.3, which is the loopback 0 of PE2. Also, we can check on the peer and we can find that the peer with PE2 is already established. Now, configure the VPN instance with a tunnel policy. I have to configure first the tunnel policy. The tunnel policy is configured with command tunnel policy. I'll give it the same name of the VPN instance, and I'm going to add command tunnel select sequence CR/LSP. It means that I'm going to select constrained LSP, which means a TE tunnel, and I'm going to use the keyword load balance number. Then I can specify how many CR/LSPs can be used. I'll specify number 2 to be able to use tunnel 1 and tunnel 2. If I have another TE tunnel on another available path, I can change this number to 3. Next step is to apply this tunnel policy to the VPN instance. IP VPN instance customer A or cust A, IP v4 family, and command tunnel policy TNL dash policy, then the tunnel policy name created above, commit, apply the same for PE2. Now display current configuration VPN instance. I can find that the VPN instance is applied with a tunnel policy, and display current configuration tunnel policy. I have the tunnel policy added. Now I have to verify that the VPN instance customer A is using now the tunnel 1 and tunnel 2. I can check that using the IP routing table, command display IP routing table VPN instance and the VPN instance customer A. I can see now that there is a network coming in IPGP protocol. This network is 40.4.4.0 and the next hop is 3.3.3.3, which is PE2, and there are two routes now available for this network. The first route is via tunnel interface 001 and the second route is via tunnel interface 002. We can check here this network using command display IP interface brief. Here we have the interface Ethernet 102 at PE2. We can check on this interface. This interface is connected to CE3 and is binded with customer A VPN instance, and it has an IP address 40.4.4.1, which is in the network received at PE1. Display IP routing table, VPN instance, customer A. We can find that network 30.3.3.0 is coming in the IPGP protocol from the next hop 1.1.1.1, which is PE1, and the outgoing interface over two TE tunnels, tunnel 2 and tunnel 1. Ping from CE1 side, we can ping CE3 side, which is 4442. We have replied successfully from CE3. Thank you for viewing this video. I hope it can add a good value to you.